Hello, everybody. This is Mr. Dorsey. I wanted to go ahead and show the basics of the code and how the pulse sensor actually works. So just show you all the sensor that I'm using. It's really, really cool because it uses infrared light. You can see the infrared light actually penetrates through my finger, and that's part of the lesson today. The pulse sensor is actually sending out infrared light. It's bouncing off of the hemoglobin and is absorbed at different rates based on if your blood is oxygenated or not oxygenated, and it's picking up that small difference in signal. So let's go ahead and look at what the output of your sensor would look like. I've been running mine for a while, and every time my heart beats, let me adjust my pressure of my finger. I will say that this sensor is very sensitive to how hard you push down on these sensors. So it's really critical you keep your pressure near constant. So you see that I have it go up and down and up and down and up and down and up and down, and it's going over and over and over again. Every time it does that rapid shift down, that's right when my heart pumps. This is using infrared light. So right when my heart pumps, that rapid shift down is happening. Our nursing staff will talk about why that happens later this week. So that's what we have as far as the output, what it looks like. Now let's go ahead and look at what code looks like, and I'm going to talk about that. So you're going to need two libraries, and I'm going to teach you all how to do that during class. Let me scroll to the left a little bit. Then we're defining the actual type of particle sensor that you have. And then we're starting the serial monitor. This line's not actually needed. I'm going to go ahead and delete that for your all's code now. Then this part is specifically for the serial monitor. It's essentially just getting the particle sensor, loading the library. Then if it turns out to be collecting data too fast, that's essentially the sensor knowing that your finger's not there. So it will tell you through the serial print that your finger's not there, there's a problem. So that's just something for you to know going in. The next part of this is all of the constants. So I went ahead and took these out, and I made them a comment below. In your code, I'm going to talk about this. This won't be there in yours. It's only there for mine. This is all of the constants that we're going to use for the library for the particle sensor to work. So the particle sensor setup has some initial conditions. So let's go ahead and look at what these initial conditions mean. This first cell is defining how bright the LED is on the light. Let me show you what that is. That's the brightness of this light in here. There's several different LEDs of different colors, and we'll talk about that in a second. Let's go back to the code. Then we have the sample averages. That's how many samples it takes in rapid succession before sending a printout. That way, if just one value just happens to have some noise in it, it'll average them out. I've picked for each time it outputs one value in the plotter to be an average of 8 values. The next cell is the mode of the LED. There's several different options. One's only using the pure red color. Two's using the red and infrared, and three's using red, infrared, and green LEDs all at the same time. I went ahead and just chose to do all three of them. The sample rate, slower is going to be better. The problem with slower is that you're going to have a lot of different readings for this. So we want a fast sample rate, and because of the following. So I'm going to open back up the serial plotter, share screen. See how quickly this is scrolling to the side? If I had a slow sample rate, and also this is random noise. My finger's not even on it, see? So notice why you're going to want an average of a bunch of different samples. Note that as since it's solely measuring reflection, if I have my light here, if I just put my finger in the way, you can actually get the sensor to measure different amounts. Note my sample rate's happening so fast, so once I put my finger there, it'll get a very high reflection, and the reflection will change very, very little because my finger's only really changing by a little bit of pressure, and my blood pulse is what I'm trying to measure. I picked a fast rate because see how quickly it's going to the side? It's going to auto scale, and then we're going to see my pulse right there. And now you can actually see the rapid shifts down, and I picked a very fast rate of samples just so that this scrolls by quickly. And now I take my finger off, and you see the auto scale makes it not even visible. Let's go back to the code, share screen, code, and then my pulse width. I'll be honest, I don't actually know what these last two things mean. Maybe you can look it up on your own. But hopefully these parts help out. I have played around with the sample rate some. I like the faster. Played around with the brightness. I think the red, infrared, and green makes the best signal, and I think the sample average of 8 is good enough. So nothing in this comment text you need. This is only here for me to know what the settings mean. The default settings were this. So I played around with it a little bit in here. So now let's go ahead and go back. This is the little bit of harder part of the code. So I'm going to talk about why it's going on. First thing is just to show you the serial monitor. I want you to notice that on the x-axis, if I get rid of this, go back to tools, go back to the plotter, and I want to show you the x-axis. Note that there are 500 values in the x and y axis, in the x-axis. It's going to be important because if I don't take 500 samples before the plotter starts, the values will start at 0, then make a measurement. So you're going to have this rapid shift. I'll show you what that looks like. It'll look like this, and notice how you can't see my pulse. Then when I put my finger there, this has to scale up to over, what's that, 100,000 right off the bat. So if I take 500 samples to start off, note it's almost done taking 500 samples, it'll be able to auto scale to about what your values are. So I need to populate the graph with 500 values, so this happens. And that was just a workaround. I brainstormed for a while to figure that out. Here's back to the Arduino. So this is what's going on. I'm saying some value for X, it's going to go up to 500 values and add 1 each time. That's what X++ means. So this is all in the setup. Note I'm not even in the loop yet. So it's going to keep printing the base value, where the base value is going to be averaging. I'm going to pick an average of 16 times just to make this code populate a little faster. So it's going to take 16 measurements, average it, and then turn it to the serial monitor. It's going to repeat that 500 times, and that's just going to pre-populate the graph. That's so the serial monitor starts at the correct zone, zoomed in on the y-axis. Then the whole code that you need is just printing the particle sensor's data value. I'll show you what happens if we don't have any of this auto-scaling math. So I'm going to copy, exit, upload it back to the board. Now what did I do? A function defined here is not allowed. If, I needed, there we go. Yep, now that error message was saying essentially is that my setup function did not have a curly bracket at the end. So now it's done uploading. Let me show you why we really needed that, that code in there. So let me exit out, let me tools, serial plotter, new share, and look at what it did. So it measured 0 a couple times before the sensor populated. And now I have to wait forever before my 500 data values are taken. And then it'll start to auto scale. So that's why I put this code in here. So let me go back and show you that. Again, is saying, okay, I'm going to take 16 measurements. I'm going to measure 16 times, add them together, and divide by 16. This is taking the average. Then I'm going to take the average and print it on the serial plotter 500 times, and that's just to clear the serial plotter out so that it starts scaled to the values that your finger actually is reflecting into the sensor. I hope that helped. I hope this was informative, and I hope you all are having a good time at camp.